The operator extends the Kubernetes API through custom resource definitions. Hello there, and thank you for joining me for another day of 100 Days of Kubernetes, the challenge where we aim to learn something new related to Kubernetes across 100 days, and me sharing with you here on my channel. You can either follow the entire challenge, create your own challenge and contribute to this one, or just nitpick different videos depending on what you prefer. Now for those who are new to my face, and me without glasses, my name is Anais. I'm a developer evangelist, and I'm pretty much getting started with all of these. So I'm a newbie, and I'm telling my newbie experience. So, in the past video, we looked at Prometheus. Specifically, we used the Prometheus operator to use Prometheus to tell Prometheus which application it should monitor on our cluster. Now, I mentioned operators, Kubernetes operators, several times within the past videos, but I never quite explained what they are and the magic behind them. Let's get started. Okay, so we are back on our drawing board. To understand Kubernetes operators, we have to understand several different components around Kubernetes and how Kubernetes interacts with and manages our resources. Let's assume this is our Kubernetes cluster, and within that cluster we have a few different nodes. Let's say 4 nodes. And they interact with each other, they manage our resources, they take care of our resources, and so on. And this is our Kubernetes cluster, so we also have Kubernetes running on it and basically taking care of everything, right? Doing the magic. So, in order to tell Kubernetes what resources to deploy, we, for example, need YAML files. So we have, let's say, 3 different YAML files. They are all different resources. So let's say one describes our deployment, another one is the replica set that our deployment depends on, and the other one is maybe the service that allows us to access our deployments. Now, in order to tell Kubernetes about these resources here, we have to communicate through, for example, kubectl, in most cases, with our Kubernetes API. Now, in several cases, and this is something that you might want to take note of if you're not familiar, these different YAML files depend on each other, right? There's a specific order to it. So if you follow more complex documentation, you might want to make sure, you do want to make sure that you deploy those different resources in the order that they are described. It's usually not mentioned, but the order matters in order to make it work. So in this case, for example, this could be the first one that has to be deployed. This could be the second YAML file, YAML definition that should be deployed, and this could be the third one. So once these are all within our cluster, they will be scheduled, like our pods will be scheduled on those different nodes. And let's say we have a replica set of 3, and they will be running within those nodes. Now, this is all magic that's taking place from the Kubernetes main node. It's taking care of scheduling our pods, making deployment happen, and so on. Now, in many cases, it could happen that one of those pods dies, right? It fails because of different reasons, various reasons that could be responsible for it. Now in Kubernetes, we have control loops. And these control loops are responsible to consistently check the state of our cluster and compare our current state in our cluster with the desired state that's defined within our resources. So it basically wants to make sure if the replica set states that there should be 3 replicas and one of them dies, another one should be spin up again on our cluster. And through that, Kubernetes makes sure that our current state matches our desired state. Now, if we don't have those control loops, it could happen that just a pod dies and nothing's going to happen. Kubernetes is not going to take care of re-spinning up those resources. However, we always want to have exactly the resources that are defined within our YAML files. Otherwise, we can't really make sure that actually what's happening with our cluster is what's supposed to happen. So these control loops are going to be really important in a second. Now, if we have more complex applications that rely on several more YAML files, let's say a 5th one and a 4th one, these all have to be deployed within this order. It's going to become really, really tiresome and annoying to deploy them one by one, or if something goes wrong, to have to delete them one by one, right? So what you could do is you could pack it up into a nice Helm chart. And we took a look at Helm charts in the previous videos as well. Now, this is the case, for example, for stateless applications. You would then deploy those resources and they would be working on your cluster. They would do its thing as described in the YAML files. They would maybe some cases the pods would die and be respun up and so on. Now what happens if you want to deploy a stateful application? So the difference between stateless and stateful. We also took a look at Kubernetes volumes in one of the previous videos. In some cases, you actually want to keep the state of your Kubernetes cluster. You want to be able to rely on a consistent state. If users going to try out your application, going to use your application, you want to be ensured that whatever they append to the state of that application is going to become the most recent state, it's going to be kept. However, if the pod that takes care of the stateful application dies and is respun up, we might lose that state, which is obviously a problem. So in those cases, you would have a human monitor the cluster. This would be a human operator who is monitoring the cluster. However, as we know, humans are really, really bad in doing manual, time-consuming, boring tasks, such as observing the state of something to make sure nothing breaks. It's not such a good idea to have humans do that. So this is where operators come in. And operators are basically responsible to make sure that whatever is happening within our cluster, all those resources are deployed within a specific order, they are managed and so on, and they operate as how they are supposed to. So if we assume that we have, for example, here we have a MySQL database, those are MySQL databases, and they take care to record the data of our front end, whatever is inputted into our front end application. So we have maybe additional pods that are our front end, and they communicate with those pods that are in our back end. They could also be running on the same node, doesn't really matter. So the point here is that we have a front end and a back end, and the back end has to record the persistent state. And the problem is, depending on which database we use, all those different vendors have different workarounds on how the database ultimately is managed within our Kubernetes cluster. Now, first of all, we would have to learn it. We would have to make sure that everything is working properly and so on. That's really tiresome, complicated tasks. So what we could do instead is use operators to take all of that workload from us. Now, operators are usually developed by the people who know the application the best, who are really familiar with the application and know how to handle it so it would work properly within our Kubernetes cluster. So those operators, what are they actually? So an operator in itself is basically an extension of our Kubernetes API. The operator extends the Kubernetes API through custom resource definitions. What are custom resource definitions, you might ask? What is that now? Now, ultimately, in its most simplest form, those are other Kubernetes resources that extend and utilize the Kubernetes API, the existing Kubernetes API. And through using that, we can extend the functionality of our cluster. So we can make our cluster work with stateful applications and run stateful applications like they are supposed to be run to run correctly and to keep track of our resources and everything that we need to have within our cluster. So operators use custom resource definitions and they use controllers. Basically, they rely on those control loops. Now, a controller within physics, mechanics, and so on basically just makes sure that whatever is happening is actually supposed to happen. That basically the desired state, the actual state matches our desired state. So the control loop, in this case as well, is making sure that everything is running correctly, that the resources that we defined to manage our backend and our front end and so on are running properly, are correctly implemented within our cluster. And this is ultimately what operators are. Now, there are a variety of different operators, and Prometheus, the one which we looked at yesterday, is actually the first one, I've been told, I didn't verify that has been developed, which is a really cool concept because through operators, you can extend the functionality of Kubernetes and you can make it work for your application and for your use case. Now, like always, you can head over to my public Notion page where I keep all of my notes publicly on this 100 days. At the end, we have Kubernetes Operators, an overview of operators, what they are, some additional resources, as well as how they are developed and where you can find them. Now, there's an operator framework that can be utilized to develop Kubernetes operators and basically make it easier for people to develop within the community to develop new operators. You can also find all kinds of operators within the operator hub, That's also linked in the Notion page, so check that out. Now this is it for today. I hope it was useful. If it was, please remember to give it a thumbs up and subscribe to my channel for upcoming videos. I would highly appreciate your support. Also, we have a Discord community link below that you can join now to get involved. Maybe you have some questions. Maybe you want to share your experience. We would love to hear from you. I hope to see you in one of my upcoming videos. Have a lovely day. Bye bye.